Hello friends, welcome to lecture number 6. Here we're going to discuss about Fourier series change of intervals. Okay, and we're going to solve these two problems, right? So I have given the links in the description box, links of the previous lectures from 1 to 5. So if you haven't watched those, then you may go through. And before we start, please subscribe the channel. Also share with your friends, hit the thumbs up button, also hit the bell icon so that you get notified when new video will be uploaded, right? And now let's start. From lecture 1 to lecture 5, so far we have discussed about expansion of functions as a Fourier series in the interval like minus pi to plus pi or 0 to twice pi, right? These are of length twice pi, right? These are intervals of length twice pi. So if we have a function in the interval of length twice L, suppose twice L, so it is not in terms of pi, then how to solve those problems? It may be minus L to plus L or 0 to twice L. That means you can take as an example a function in 0 to 2 or minus 2 to plus 2. In such cases, how to solve those type of problems? So let me show you now. Now you see, suppose we have a function f of x which is defined in this interval 0 to twice L. The Fourier series of this function will be given by this f of x is equal to we know that the Fourier series is given by a naught by 2 plus summation n is equal to 1 to infinity a n cos x cos nx, sorry, not cos x, plus b n sin nx. So here a naught will be equal to 1 by L integration 0 to twice L f of x dx. That is how we have to find the a naught, right? So hope you have understood this. So just wait. So let me write here this one here. Okay. That's how we need to find a naught, right? This is how we need to find a naught. Now how to find a n? The formula to find a n, that's going to be equal to 1 by L integration from 0 to twice L f of x cos n pi x by L dx. Okay, that is how we can find a n. Now bn, how to find bn? Bn will be equal to 1 by L integration 0 to twice L f of x sin n pi x by L dx. That's how we can find bn. We have got a naught, a n and bn. Now let us solve this question. So here you see, so this is the function and this is the interval. So here let me write the function first and the interval. Just copy this one. So here is the solution. So this is the function in this interval 0 to 3. So here we're gonna compare this interval with 0 to twice L. Okay, we're gonna compare this interval with 0 to twice L, right? So then what we're gonna get here, you see. So here you will get twice L is equal to 3, and hence L becomes 3 by 2, right? So just wait. So let me write the Fourier series also. Just let me clean this one. Now here we have to write, let this f of x or this function be equal to a naught by 2 plus summation from n is equal to 1 to infinity a n sin, sorry, not sin, cos nx cos nx plus bn sin nx. So this is suppose equation number 1, right? So now you see this L is equal to, now we have got 3 by 2. So if you use this value in equation number 1, this equation number 1 becomes, so equation number 1 becomes this, right? So let me take this as equation number 1, this one as equation number, sorry, not 1, equation number 2. Let me take this as equation number 2. Suppose this is equation number 2. Now here you can see what we have done. We have replaced this L by this value of L, right? We have used this value here. Then we have got this equation, right? Now let me copy this equation and let me go to the next slide. Okay, so here we have not enough space, so let me go to the next slide. Okay, so this is the equation we have got last. So here, how to calculate an. Sorry, first let me find a naught. Okay, how to find a naught. So here we know this is how we can find a naught, but here L is equal to, putting L is equal to, so we have got L is equal to 3 by 2. If you put L is equal to 3 by 2, then a naught will be equal to 2 by 3 integration 0 to 3. If you put here 3 by 2, then 2 into 3 by 2, 2 will be cancelled, only 3 left. So that's going to be the upper limit, right? So hope you have understood. I don't think that you have problem. X plus x square, f of x, we know here the function is x plus x square. Here is the function, right? This is the function, you can see clearly. So dx. So now if you integrate this, and then what you will get, 2 by 3 and x square by 2 plus x cube by 3, and lower limit is 0, upper limit is 3. And if you evaluate this, then what are you gonna get? You're gonna get 2 by 3. If you put 3 here, then it's gonna be 3 square by 2, and if you put 0, then this term becomes 0. So let's move to next term. Again here put 3, so then 3 cube by, then you will get 3 cube by 3. Again if you put 0, you're gonna get 0. So if you evaluate this, then what you will get, let's multiply this 2 by root 3 with this 2, then you will get 3 by sorry, not 3 by 2, only 3, because 2 will be cancelled, 3 cancel. And if you multiply this 2 by 3 with this, then you will get 3 square by 2 into 3 square, right? 2 into 3 square by 3, that means 3. That's what you will get. So 3 plus 6, that's going to be 9. Okay, so hope you have understood this multiplication. This is simple multiplication only. What we have done, we have multiplied 2 by 3 with this and this, right? And after cancellation and addition, we have got this 9, right? Okay, this is the value of a naught. This is a naught is equal to 9. So we have got a naught. So let's find an. Okay, so how to find an? We know that. Again here put the value of L is equal to 3 by 2, and doing so what you will get, this an will be equal to 2 by 3 integration 0 to 3. F of x is here x plus x square, and then you will get cos n pi x by you're gonna get twice n pi x by L, sorry, not L, 3. Okay, that's what you will get, dx. Now integrating by parts, that means if you use if you take this one as u and this one as v, then if you use this integration of u into v is equal to u v1 minus u dash v2, then plus u double dash v3, and plus so on. Then what you will get, I have already explained in previous lectures how to use this rule. So here v1 represents integration of v, right? And u dash is derivative of u, ddx of u, and similarly u double dash will be ddx of u1, u dash, ddx of u dash. So and v3 will be integration of v2, right? v2, integration of v2, and v2 is integration of v1. So first let us take here 2 by 3, then okay, first what we're gonna write, u is here x plus x square, right? Then v1 is integration of this is the v, so v1 is integration of this. If you integrate this, then what you're gonna get, you're gonna get sine 2n pi by n pi x by 3 divided by again 2n pi by 3. That's what you're gonna get, right? Then minus then u dash. If you differentiate this, then what you're gonna get, 1 plus twice x, right? Then v2, that means integration of this. If you integrate this again, then you're gonna get minus cos of this twice n pi x by 3, right? Divided by square of twice n pi by 3. Okay, it's a square. That's what you will get. And this minus becomes plus, so we can write here this is as plus, right? And then in the next term what you will get, then plus u double dash means derivative of u dash. U dash is this one, so if you differentiate it, then you're gonna get 2 only, right? You're gonna get 2 only, and integration of this part, right? Integration of v2, that means v3. So integration of this will be again sine just wait, of sine of 2n pi x by twice n pi by 3 cube. That's what you will get, right? So we are integrating it from 0 to 3, right? So lower limit is 0, upper limit is 3, and in the next term derivative of this 2 will be 0, so we have to stop here. Okay, so now let me copy this result of an and let me go to the next slide. This is what we have got, an is equal to, and let me tell you one more thing. Let me go to the first slide here. So in this case n is equal to 1 2 3 4 and so on up to infinity, right? So here you see, so let's get back to this slide. Here you can see for n is equal to 1 2 3 and so on, this value of sine n pi is equal to 0. Okay, value of sine n pi is equal to 0, right? Now you see, so it doesn't matter 1 pi 2 pi 3 pi 4 pi, so integral multiple of pi is there, then sine value of integral multiple of pi, that gonna be always 0. So here you see, when you put this upper limit here and here, then what you will get, sine 2n pi into 3 by 3 gone, then you will get sine 2n pi. This is 2n, this 2n is also an integer, so it's gonna be equal to 0, right? And when you will put 0 lower limit, then this whole thing is gonna be 0, so sine 0 is again 0. So that's why we're gonna ignore these two terms containing sine, right? Just wait. So we're gonna ignore these two terms because these two gonna be 0, right? So we're gonna deal with only this term, term consisting x only, right? So now let's put upper and lower limit. An is equal to 2 by 3 into, so what if you put here 3, then it will be 1 plus 2 into 3, right? Then cos 2n pi. So if you put here 3 gonna be cancelled, right? So hope you have understood this. And divided by 4n square pi square by 9, then minus, if you when you will put 0 here, here also 0, then this twice x will be 0, and cos 0 is 1, so that's why 1 into 1 by 4n square pi square by 9. That's what we have got, right? So now cos of n pi is 1 minus 1 to the power n, but we have cos of twice n pi, that's going to be minus 1 to the power twice n. So twice n, it must be even, so that's why its value must be plus 1. So that's why what we're going to get, we're going to have an is equal to 2 by 3. You can take this term common, right? And if you do so, then what you will get, you will get here 9 by 4 n square pi square, and within bracket you have 1 plus 6, that's going to be 7 into, and value of this is 1, so 7 into 1 minus 1, that's what we have got. So 2 by 3, so let me write here, just wait, one more thing, cancel this 9 by 3, then you will get 3 here, and 4 by 2, right? That's what you will get. So value of an gonna be is equal to here 3 by 2 into 1 by n square pi square. So 7 1 the 7 minus 1, that's gonna be 6. So if you cancel this, then it's gonna be 3. So final value of an will be equal to 9 by n square pi square. So this is the value of an, right? This is the value of an. Now let's find bn. Okay, so this is how we're going to calculate bn. So here l is equal to 3 by 2. We know we have got this from the value of l. So if you put this value of l, then bn will be equal to here 2 by 3 integration from 0 to 3, right? Then f of x is again x plus x square, then sine n pi x by l dx. Now how to evaluate this such type of integral I have already explained, so let me write the result directly. So after integration you will get this result, right? And here we have applied this rule, because I have already explained how to apply this rule, so that's why I have skipped that explanation. So this is the result. Let me copy this and let me go to the next slide. Okay, so here let me tell you one more thing, this minus will be plus, right? Here you can see, so minus these two terms are going to be positive, right? So here we can write directly plus. Okay, so let me take this result and let me go to the next slide. Again, as I have already said that sine n pi is 0, sine n pi is 0, so that is why we're gonna ignore this term, right? Again, when you will put this upper limit 3 here, that's gonna be a sine twice n pi, so 3 will be cancelled, right? That's why it's gonna be 0. And if you put 0, obviously sine 0 is 0, so that's why we're going to ignore this term containing sine. So we're going to deal with only these two terms containing cos, right? So here bn gonna be equal to, let's put the upper limit and lower limit, do the calculation, and then you're going to have the result value of bn. So if you put 3 here, what you will get, 3 plus 3 square, and if you put 3 here, then it's going to be cos 2 n pi. So here minus cos 2 n pi, 3, if you put 3 will be cancel each other, so then divided by 2 n pi by 3, right? Then minus, again if you put 0 here, this thing is gonna be 0, so 0 into anything is 0, so let me go to this term now, plus. Here you can see, if you put 3 here, this 3 will be cancelled in that case, then you're gonna have cos 2n pi by 2n pi by 3 whole cube. That's what you will get. Again, if you put 0 here, you're gonna have minus 1 by 2 pi 2n pi by 3 whole cube. That's what you will get, right? So hope you have understood this. Now let me copy this result and let me go to the next slide. Okay, so one more thing, I forgot to multiply these two. These two should be multiplied here, right? So let me go to the new slide. Just wait. So this is what we have got, bn is equal to, right? So now you see, okay, bn will be equal to 2 by 3. So here you get 3 square 9 plus 3, that's gonna be 12 into this, and here we're gonna have minus, and cos twice n pi, I have already said that should be 1, and this 3 goes up, right? So if you simplify this, simply you will get this 3 by 2 pi 2n pi, right? Then here you're gonna have 2 by 2n pi by 3 whole cube minus 2 by 2n pi by 3 whole cube, right? So you're gonna get this, and this cancel. So here you see value of this is 1, and value of this one is also 1. So this minus, because of this minus, here we have got minus. Okay, so 2 6 12, 6 3 is 18, right? So then what we will get bn is equal to 2 by 3 into minus 18 by n pi, right? N pi and 3 cancels, 18 gives 6 times 6 to does 12, so minus 12 by n pi. That's what we have got. So this is the value of bn, right? This is minus 12 by n pi. So this is the value of bn, right? So we already have got the value of a naught, an, and bn. So let us use these values in equation number 2. Okay, so let me go to the new slide. So what value of a naught, we have got 9. Value of an, we have got 9 by n square pi square, and value of bn, we have got minus 12 by n pi. Let me check once again. So this is the value of bn, minus 12 n pi. Yes, that is correct. Okay, so let me check n. Okay, so here is the value of n. Here you can see this is the value of an, that is 9 by n square pi square. Then a naught is 9. This is the value of a naught, 9. So let us use these three values in equation number 2. So using these values in equation number 2. So what was the equation number 2? So here is the equation number 2. This is the equation number 2. Let me use so put the value of a naught here. A naught is equal to 9. Put this one here, and put this value of bn here, and doing so, what you will get. So this is what we have got after putting those values in equation number 2. So this is the result we have got, which also can be written as x square plus x plus x square 9 by 2, and this 9 by pi square can be taken out, right? Plus 9 by pi square summation from n is equal to 1 to infinity 1 by n square cos twice n pi x by 3, then plus here it's going to be minus, this minus is taken out, and 1 by 12 by n, right? 12 by n summation from n is equal to 1 to infinity. So sorry, not 12 by n, 12 by pi. 12 by pi is taken out, so 1 by n. Sorry, this bn is not necessary here because this is the value of bn, right? So this is the Fourier series we have got, then sine twice by nx by 3. So this is the final result we have got. Sorry. So hope you have understood this. Now let us solve the next problem. Okay, so what was the next problem? So this is the question we are to solve now. Here you see, so let me write the given function first. Now here you say this is the given function, this is the given function. If you see this interval, okay, this is not in this form 0 to twice l. Okay, this is not in this form, this is in this form minus l to plus l, right? So here 2 will be considered as l, right? So in the previous in the last problem we had the interval 0 to 3, right? 0 to 3. So in that case we had compared it with 0 to 2l, so 3 was equal to twice l. But here in this time we have to compare this one with minus l to plus l, right? We have to compare with this, so l will be equal to 2. And in such cases when you have the just let me give you the note properly. Just suppose this is the function. If you can see, if f of x, if the function f of x is defined in minus l to plus l, then the Fourier series will be as usual f of x is equal to a naught by 2 plus summation from n is equal to 1 to infinity, so a n sine cos n, not only n pi x by l plus bn sine n pi x by l. That will be the your Fourier series, and an will be a naught will be l by 1 by l minus l to plus l f of x dx. That gonna be the a naught, and an will be equal to 1 by l minus l to plus l f of x cos n pi x by l dx, and bn will be is equal to 1 by l, so 1 by l minus l to plus l f of x sine n pi x by l dx. That's what you will get. Now here you what if f of x is even function and odd function? So let me copy these things, let me go to the new slide, let me take a new slide to explain these things. Okay, just let me paste here. So now you see these results can be also written as here you see, using the properties of integrals, you can write this result a naught is equal to 2 by l. Now this interval will be changed to 0 to l, f of x dx, and similarly it also can be written as 2 by l 0 to l f of x cos n pi x by l dx, and similarly bn also can be written as 2 by l 0 to l f of x sine n pi x by l dx. That's how you can write. Hope you have understood this. Now you see, remember one very important thing, that if this f of x is even, then bn is equal to 0. In that case we don't need to calculate bn, right? Okay, so if f of x is 0, then we're going to take f of x is even, then we're going to take only a naught n okay. We are not going to calculate bn, okay. And next condition, if f of x is odd, in that case, if this is odd function, right, then we're going to take a naught and a n is equal to 0, then these two values will be 0. We don't need to calculate these two values. So remember these things, okay. These are very important points, so remember these things, okay. So now let us go back to the problem. Let us solve this equation and solve this question now. So this function is, this is an even function. So what do you mean by even function and odd function? If you don't know, please watch previous lectures, okay. Then you will understand. So okay, let me explain it again. So if f of minus x is equal to f of x, then it is even function. If f of minus x is equal to minus f of x, then it is odd function, right? So just remember these things. So here you see, if you put here minus x, f of x, if you replace the x by minus x, then this will be minus x square minus 2, which is again gonna be x square minus 2. So here in this case you can see f of minus x is equal to this, that means this is f of x. So that is why this is even function. So hope you have understood this. So just let me clear this. So it is even function. In this case, compare this interval to with minus l to plus l. So in that case, here value of l will be equal to 2, right? And as it is even function, for even function I have already explained that bn is equal to 0. For even function bn is equal to 0. So therefore our Fourier series for this function can be considered as only x square minus 2 is equal to a naught by 2 plus an summation. I have forgot the summations. Summation from n is equal to 1 to infinity an cos n pi x by l, right? This is equation number 1. This is equation number 1. And putting the value of l here, we will get x square minus 2 a naught by 2 plus summation from n is equal to 1 to infinity an cos n pi x by 2. That's what we will get, right? So instead of this, let me take this one as equation number 1, okay. That's fine. So now we know that a naught is equal to now 1 by l integration minus l to plus l, but we can change it to 2 by l from 0 to l, right? From 0 to l. This is the property of integral. So f of x dx, right? So here f of x is this one, x square minus 2, right? So we can write l by here value of l is 2, so 0 to 2, then f of x is x square minus 2 dx, right? That's what we will get. So here 2 cancels, gives 1, and integration of this will be 0 to 2. If you integrate x square, you're gonna have x cubed by 3, 0 to 2, then minus 2 integration of dx, that's gonna be x, right? Again we are integrating it from 0 to 2, right? Now if you put the upper limits and lower limits, let me copy this result and let me go to the next slide, okay. So this is the last result we have got, and if you put the upper and lower limits, then what you're going to have 2 cubed by 3 minus if you put 0, then it's become 0, so then again 2, putting here 2 you will get 2, then putting 0 you will get 0, so that means it's going to be equal to 2, right? So here 8 by 3, then 4, then 8 minus 12 by 3, that's going to be minus 4 by 3. So this is the value of a naught. So we have got the value of a naught. Now let's find b naught, an. Let us find an. So an will be equal to, an is equal to 1 by l minus l to plus l f of x cos n pi x by l dx, but it can be changed to 0 to l if you write here 2 by l. Okay, if you write here 2 by l, so let me write here properly. 2 by l integration 0 to l f of x cos n pi x by l dx. So here you see value of l is 2, so we're gonna write 2 by 2, 0 to 2, f of x is x square minus 2, and cos n pi x by 2 dx. That's what we're gonna. So now in this case we're gonna apply this rule. Okay, so we're gonna apply this rule to integrate this. Then doing so, what we will get x square minus 2. How to apply this rule I have already explained many times, so watch all my videos, so then you will understand. And I have already explained in this video also, in the last problem. So you're gonna get this sine n pi x by 2, then divided by n pi by 2 minus twice x minus cos n pi x by 2 by then n square pi square by 4. That's what you will get. Then the last term will be plus 2 minus sine n pi x by 2 divided by n cube pi cube by 8. That's what you will get, and we are integrating it from 0 to 2. Upper limit is 2, lower limit is 0. So here you see, we know again that sine n pi, that is sine n pi for n belongs to z, that means if n is integer, sine n pi is equal to 0. So I have explained in the while solving the previous problem as well. So here if you put the upper limit, then 2 will be cancelled. Upper limit is 2. If you replace this x by 2 will be cancelled, and we will get sine n pi, which is gonna be equal to 0. So terms containing sine gonna be 0, right? So we're gonna deal with only this term, right, and put the upper limits and lower limits. Then you're gonna get the value of an. Let me show you in the next in the next slide. So this is an. So here this minus it's gonna be plus, and minus plus it's gonna be minus. So we can write simply here minus 2 this. So here, as I have already told you, that since n sine n pi is equal to 0 for n belongs to z, so that's why we're gonna ignore these two, and an will be equal to, just put the upper limit and lower limit here in this middle term only. So then what you will get, 2 into 2 cos n pi 2 by 2 by n square pi square by 4 minus, if you put 0, then this will be also 0, right? 0 into anything, that's 0. So here we have got this value only. So then 2 to the 4, that's going to be 16, right? 16 n square pi square, and here 2 cancels, sine n cos n pi is minus 1 to the power n. That is what we will get. So this is the value of an we have got, right? And here, since the function f of x that we had here, x square minus 2, is even, so bn will be 0. So that's why a naught and n, these two values are enough. So let us use this value a naught and n in equation number 1. Okay, so these are the values of an and a naught. So using these values of a naught and n in equation number 1, So what was the equation number 1? So this is the equation number 1. Okay, so here we're going to use this value of an and a naught. So just wait. So let's put the value of an. So this is an. So what we have got, an is equal to, we have got an is equal to this. Okay, let me use this value here. So just wait. So let me use the value of an here, that is 16 n square, 16 by n square by m pi square minus 1 whole to the power n, and let us use the value of a naught, that is minus 4 by 3. So if you use here minus 4 by 3 divided by 2, then it's going to be minus 4 by 6, right? If you okay, minus 4 by 3 by 2 cancels 4, so it's going to be minus 2 by 3. So hope you have understood this. Now you see from here, so this is the result we have got now. So what I have done here, here I have put values of n from 1 to infinity to expand this series summation, and then I have taken minus 16 by pi square common from each term, so I got this answer. So hope you have understood this. If you have understood this, please share with your friends, help me to create new contents, help me to grow my channel, inspire me to create new contents for you, and stay connected. And if you are new to my channel, please subscribe the channel, hit the bell icon so that you get notified when new video will be uploaded. Okay, so thank you for watching. See you in the next video.